In this video, we are going to talk about the different surface types you can generate from 3D scan data. All right, to get started, let's kind of go over what we want to accomplish in this video. First thing we'll do is we'll define what a surface is versus a solid, and we'll go into more detail on when we refer to a surface, what that is versus a solid. And we'll explain what all of those are, what those two things are. We'll also talk about why you would create surface or solids. We'll go then in depth and detail on the different surface types available. We'll kind of go into how they're created, and this will be interactive. We'll go into some reverse engineering software, and we'll kind of show you how that's done. And we'll show some different samples and different applications and how you would use the different types of surfaces. So we're really going to take a deep dive into the different surface options, and then finally we'll wrap up this video. All right, to get started, I would recommend, if you haven't watched our video called 3D Scan Output Options, you might want to go watch that first. And I'll put a link in the description below to check out that video. And really any videos on our website. There's over 100 in-depth videos. But this video goes into a lot of detail about the different output options for 3D scanning, including surfacing. But in this video, we're going to drill down into the surfacing options in a little more depth and detail. We didn't do it in that video because it just gets too maybe confusing for some people, and not everybody needs the type of surfacing we're going to talk about here in this video. But if you want to watch that video first, I would encourage you to do that and then come back and watch this. This video is going to go in a little more depth in the different surfacing options you have. This generally is for people doing more what we call freeform or organic types of models and surfaces. And of course, if you have any questions on any of this, feel free to give us a call at 877-845-2700, or you can send us an email at info@ems3d.com. But next, we'll go into more detail on some of these specific surface output options you have from 3D scan data. All right, let's talk about what is a surface and what is a solid and how we're going to define them in this video. Now, the words surface and solid, if you use a 3D CAD system, those are pretty general terms to describe things, but they're not always may have the same meaning to everybody. So I'm going to kind of define what we're generally talking about here in this video. So when we're generally talking about a surface, what you see on the left is what we would mean. It really means something that has no thickness to it. It might be a very organic shape, but we also refer to them as skins. Some people call them skins. So it really has no mathematical thickness. It's just some shape. And generally, why you would use this is because it has a lot of free-flowing shape to it. What you see on the right in the gray is we're going to define as a solid. And what that means is you've either extruded it down, or you've offset it, or you've given it some thickness so that now it's like a body. Okay, so another term you might hear is a solid body, or a featured body, or a feature-based solid body. Anything like that is what we're going to kind of consider as a solid. Now, to make things a little more confusing, you can create a surface and then turn it into a solid, kind of like you see here, where we've given it some thickness, or like I mentioned, we extruded it. But that's kind of how we're going to define things in this video. And next, let's go in. Like I said, we're going to do things a little interactive here, and let's go into a little more detail on what we're referring to here. All right, so here we are in Design X. Now, if you're not familiar with Geomagic Design X, this is a very powerful reverse engineering tool. It's really the industry standard. Now, why would you use a product like this and not just your normal CAD system to do some of this? Well, let's start so we have those same two examples I had shown, but I'm going to turn on a third, and I want to zoom up. And again, we go into a lot of detail about this on our original video that we gave you the link to, but I just want to cover it real quick so you understand. So what this is here is a mesh, okay? So let's turn off the edges for a minute. So you could think of this as a surface you had scanned with a 3D scanner. And all 3D scanners output either points or polygons. And what that basically looks like, as you see here, is really just a bunch of triangles, okay? So you can see it's defined by all these triangles. Well, the problem is most 3D CAD systems cannot work with 3D scan data. As crazy as that sounds, you can import it and you have very little you can really do with it, okay? So that's the first problem, okay? So you'll notice it's all these little triangles. But if you look at the surface and the solid, and let's just hide that mesh now, you can see they're not made up of these triangles, okay? They're made up of something different. And basically what they're made up of is mathematical equations to keep things simple. And there's B-splines, there's B-reps, there's NURBs, there's all these different B-splines, there's all this different type of math that is used to build surfaces and solids. And we don't need to get into the detail of that. But the point here is this is now a mathematical surface and this is a mathematical solid, okay? So they're defined by math. And again, the main difference, as we talked about, is this has no thickness. And when you flip it over, you see there's nothing there because there's no face, so to speak, on that side. So you can see it here, and obviously on the solid there's a face. It's just the normal vector is pointing up in this case, okay? So that's the first clue in a product like Design X or any CAD system. Now, these two, since they are now mathematical, we can do a whole lot more with them, and we're going to get into that next. All right, so the next question that comes up is, well, why do you need a surface or a solid model? So as we discussed, here's the mesh, which most CAD systems can't work with. You've got to turn it into either a surface or a solid to do any kind of manufacturing, and also usually to do edits or to make changes. So for example, back to this mesh here, you really can't do much with it, like I said, in a CAD system. Well, once I turn it into a surface or a solid, during that process of creating it, I can make changes, or I can make changes to it down the road. So I'm not going to get into that too much, but generally for any manufacturing process, you have to have a surface or a solid model for CNC machining, for casting, for developing an injection mold, whatever it is. All of those downstream systems require mathematical surfaces or solids. So also scan data generally is not perfect. You're scanning a manufactured part, and when you turn it into a surface or a solid, you're probably going to make changes to it. So you're either going to just fix the inaccuracies of it, or maybe you're making major changes to it. So that's just a little bit of the why. Why do we need to go from just scan? Why can't we just take scan data and go and CNC machine it or do whatever we're going to do to it? Generally, because those downstream softwares cannot work with it. Or even, let's say, create a drawing or do some analysis. Anything like that, you've got to first get to a surface or a solid. So that's why we need to do this. And honestly, nowadays, most of the 3D scanning technology is very good and fast. It's building this geometry that takes all the time. Okay, so we'll go into some very specific types of surfaces and then look at their applications. But just to help you understand why we need to go through this whole process is you need it for downstream manufacturing. All right, so now let's go ahead and define the different surface types we're going to talk about here. Now, here's where things get a little bit confusing is I'm going to talk about them as surface models, but you notice they're all gray. And in my example where I was showing the surface skin, it was yellow. Why are these gray? Because they are all solid bodies. But how they got there was they started by building surfaces, okay? So hopefully I don't want to get too far into the weeds here. The end of the day, they're all turned into solids, but we use surface type commands to build them. And I'm going to go into more detail. So there's three main types, and we kind of alluded to two of them in that previous video I mentioned, which was the auto surface and the hybrid surface. But we're going to talk about a third one today, and you can come up with any name you want. Smart surface, some people call it an exact surface. But for now, let's just kind of look at the differences here and talk about them. First off is the auto surface, and that's this one you see here. What you basically do is you 3D scan your object, you clean up the mesh, you try to make it what we call watertight, meaning it doesn't have any holes and it's closed up. Okay. So you'll do some cleanup of the data, and then you run a command called auto surface, which basically fits this quilted patch of surfaces through it. Now, one big difference between polygons is they are triangles. At least the way we refer to a polygon, they are three-sided entities from a 3D scanner. You'll notice these are all four-sided. All surfaces must have four sides. Okay, so what it basically does is build these mathematical surfaces through the scan data as four-sided surfaces, okay? Now, the auto surface, and we're going to go interactively here in a minute, is an exact copy of your scan data. There's no difference, okay? It is an exact copy. It's just now as a surface model. And then we have a hybrid, which is a mix of surface modeling and sketch-driven solid modeling, okay? So you can see here some of the buttons look different. Right here, it's just, again, it's all just patches, right? Quad style surfaces. But you can see here, there's some differences. These are different surface types. I'll talk about that in a minute. And then finally, you can obviously see a big difference with what I'm calling the smart or exact surface, because this has been done completely differently, and it's all driven off of sketches and features and things like that. Okay, so next we'll go in interactively. We'll look at this model and we'll talk about the differences between the three and why you may want auto versus hybrid versus smart. So let's go into a little more detail here with this flight grip, and hopefully this will make more. All right, so if we take a look at, here's the scan data from that flight grip, okay, and you can see it's going to pick up everything. The knurling, got kind of a parting line here. Everything, everything the scanner can pick up, you're going to see it in this file. So if we don't change anything, so all we did was scan it. We did some hole filling to basically make this whole thing watertight, filled in the bottom here. Now you've got some editing tools. You can go in and smooth and do some different things. But basically, when you create an auto surface from a mesh, it is going to be an exact copy, like I said. So let's turn on, well, here, let's do this real quick. So as we'd shown before, here's what your mesh looks like, okay? And if you zoom way in, you can see it's just a lot of triangles. And if we take a look here, it's about 972,000 triangles make up this mesh. And again, this is not something you can use in your CAD system. And it's not something you can typically use in any kind of manufacturing system. So if you just literally run the auto surface command, and assuming it works, because depending on the mesh, sometimes it might struggle on how to build the patches, but generally it works. Sometimes you got to go in and massage the scan data. But as we'd shown earlier, it's pretty much an exact copy of the mesh, right? There's the mesh. Now, things do get a little bit washed out. Let's turn off the edges of this for a second. So you can see here, the knurling is not as good as you can see, right? And that's because when you do a surface model like this, you can't have any sharp corners. So things tend to get a little bit washed out and rounded. So that's one thing. It's not going to be perfect. It's pretty darn close, as you can see, but it's not 100% perfect. So if, again, I turn off the mesh, but generally speaking, it's an exact copy. Now, if that's all you needed, and let's say you were going to want to machine it or do something with it just like it is, technically you could use this. Technically, you can bring this into a CAD system, okay? Let me turn those edges back on. But here's the problem. Nothing is defined as kind of a separate entity. So, for example, if I wanted to maybe redesign this trigger or some of these buttons, you really can't do it, not easily, because it's all just these little four-sided patches. So how are you going to edit that? There's no underlying sketch there, okay, which is how most CAD systems work. You create a 2D sketch, and then you revolve it, or you extrude it, or you loft it. Well, there's nothing here to edit. So even if you were to do this. And this is always the fastest, cheapest option when you're doing these very organic surface types, okay? So, but again, the problem is it's not very editable in a CAD system. So yes, we can do this. Yes, it's the cheapest option, but for something like this, it's not the best option because most people want to maybe edit this. For example, if this is two plastic housings, we're going to need to split this, basically come up with a parting line, maybe shell it out, maybe add some features inside, okay? So the auto surface, this is not a good use for it. Now, I will show you in a little bit what is a good use for it, okay? All right, next, let's take a look at a hybrid. Now, we did go into hybrid modeling a little bit in that previous video I'd mentioned. And if you look, things are a little bit different, specifically some of these features. Okay, so these are more what we call sketch-driven or prismatic features. So the trigger and some of the buttons you can obviously see are different. This is a good compromise sometimes for somebody that needs to be able to edit the buttons or make changes, but the main body, maybe they don't need to make changes to. So how is this done? Well, it's called a hybrid for a reason. So let's turn off the solid for a minute and let's bring up the mesh. And I want to show you kind of what we did here. So what we had done, without getting, again, too technical, is we've cleaned this thing up. So there's the original mesh. And then here it is with some of those features deleted. So we literally went in and deleted out those prismatic or again, sketch-driven features. And then we did what's called a rewrap, which then just closes it back up, the mesh. And then we go in and we model some of those features in. So let's take a look at, let's say one of these buttons here. So that's done as a sketch, okay? So this gets more into your traditional CAD modeling right here, where we went and built this sketch and then we revolved it around. So if we turn back on the solid, right? So you can see we built this 2D profile, we found the center and we revolved it. So we basically built the four-sided surfaces everywhere except the buttons were. We cut the geometry off and we basically added those in as sketch-driven features, okay? So, this sometimes is good enough for people and other times it's not, okay? So, yes, it makes the buttons easier. It defines them better. They can have those sharp corners like I talked about. So going back to just the auto surface model, you can see, they're not necessarily sharp corners. They're not necessarily well-defined versus this one, where you can clearly see we have some sharp corners and so forth. So sometimes the hybrid model will work for you and sometimes it won't. The last one we'll look at is what we call that smart surface. So the first thing you'll notice on the smart surface here is how different it looks, okay? And instead of all those just kind of random four-sided surfaces, you can see here the surfaces are much more intelligent. There's fewer of them. And that's because it's driven more by geometry, such as sketches and splines and so forth. So now the advantage of this surface type or model type is it's much easier to edit downstream in your CAD system. It's much more, it looks different. Now, it's the same scan data as before, but when we built this, you can see it looks different because it really is. Now, so the advantage is it's a better model. It's more intelligent. You can edit it. The disadvantage is it takes a lot longer to build this type of model. For example, the auto surface model might have taken 15 minutes to clean up the mesh and surface it up. The hybrid model maybe take an hour. Something like this could easily take 8 hours or longer to build this model. But what you end up with is a much more intelligent model. So if you look, for example, just at the base here, the main feature, you can see what we had done is we created a series of sections through the scan data, and then we defined those sections with lines and arcs and splines, and then we did a loft to create the first feature. Okay, so that's what you see here. Okay. So it's much more involved, but at the end of the day, you get a much better, much more intelligent model. It also allows us, for example, you don't see the knurling on here because we would normally not model that in maybe till the very end. Maybe the knurling's going to be different. Maybe they don't want it. So you can make different decisions on how the model looks instead of just basically copying the mesh. Because a lot of times when people reverse engineer, they want to make changes to it. Okay. So this model, as I mentioned, is made up of sketches and splines, and they're lofted and extruded and so forth, right? So it takes a lot longer to do this. Now, the other thing, once this is done, we can export it as a step or parasolid or IGES file, and that's the same for all of them. But what we can also do here is what's called a live transfer from DesignX. And if we look here, we have it for SolidWorks, Creo, Inventor, Siemens NX, and AutoCAD. And what that'll do is go over here to this history tree, roll back, and actually transfer all of these features into your host CAD system. So if you want to make further changes to it, you can do that. So for example, you could go to one of these sketches, like you see here, and you could edit it and change the shape of it, which would then change the shape of the solid body. Okay, so that's what we call a smart or exact surface. It's going to be much more intelligent. It's going to give you more ability to make changes to it, either right here in DesignX or in your CAD system, and it looks more like a traditional CAD model. Okay, so that's what we call a smart or an exact surface, and this is generally what it might look like. Now, next I'm going to show you some more real-world examples of where you'd kind of use the different surface types we've been talking about. All right, so let's start with something like this, something that's more what I'd call art, architecture, or architectural, something like that, where it's completely organic. So you see this garden gnome here. There's really no way to define this thing by features. It would just be extremely difficult. This is a great example for auto surfacing. So we ran the auto surface command. Let's turn that on and let's turn off the mesh. So you can see, as we've been talking about, it's an exact replica of that original mesh that we 3D scanned. And for a lot of applications, this is fine because you're not really going to edit this with traditional CAD software. Now, there are products like Geomagic Freeform and ZBrush and others that are more digital sculpting tools that you could use. But let's just say you're going to manufacture this. You need to make a mold or something to make this, or you're just going to CNC machine it out of a piece of foam, whatever it may be. This will work. You can use this. It is all now mathematical surfaces. We can save this as an IGES step or parasolid file, where your mesh you can only save as an STL or an OBJ. Okay, so this surface model will go into a CAD system, and you can work with it. Now, you're not going to be able to edit it like you would a traditional sketch-driven CAD model, but you do have some tools to edit it. So anything like this, or this architectural piece like this, again, we converted it into a auto surface model. Again, these are a good fit for auto surface because there's just no easy way to build them any other way. Trying to do more of that smart model or a sketch-driven model, it would be very difficult, if not impossible, to do. All right, so let's show some hybrid examples. So what we have here is an exhaust manifold, and what you'll notice is part of it is very organic, like you see here, and then part of it is really just some extrusions, basically some cylinders here. So we've got a little bit of both. And let's turn on the solid body and turn off the mesh for a minute. And you can see what we have. So this is more of, as I mentioned, that hybrid model. So the main body of the exhaust here is just the patch surfaces, just kind of the random shape patch surfaces. And then the features here, the inlets or outlets, you can see are more sketch driven, right? So the sharp corners like we talked about. So this is a great example. Could we build a smart surface through here? Yeah, we probably could, but it would definitely take some time, and maybe we don't need it. So we took the 3D scan data, and we built it as a hybrid. And I'll put a link in the description below. You can actually watch the video of this whole process, how we actually modeled this, so you can kind of see what it takes to do a hybrid model versus that auto surface model. But this is a great example of a hybrid where the customer was okay with this being the way it is because he wasn't really going to edit it. And these features we definitely wanted to define as sketch driven to get the sharp corners and get the exact sizes we need. So again, this is a great example of a hybrid model. Now, this example is an example of more of a smart or exact surface model like you see here. And once again, we've got a great in-depth demo if you want to actually go watch how this entire thing was done. But it was all done with surface skins and then added thickness to it to become a surface body. And it's a floor mat. So if we hide the mat for a second, right? So here's the scan data of the floor. And then here is the mat that we created from that. And you can see, again, it's got some real complex shape and curve to it. And we did it by doing more of the exact, kind of surfacing model with lots of lofts and lots of trimming and so forth. So if you want to see this in depth, there'll be a link below to this in-depth demo video on this specific example. So to show a few more real-world examples of the smart or exact surfacing, this is a plastic fender on a Can-Am vehicle. So you can see again, more of that, exact surfacing where we're defining where the fillets and the corners and the radii are. We've certainly got some cutouts and holes that have to be very specific. But again, this is another great candidate where you wouldn't want to just auto surface this. It would make it very hard to edit and work with it. You can see this is very clean with nice, large, kind of lofted areas. So any injection molded part where you've got a lot of shape to it is a great candidate for the smart surfacing. Here's another good example. This is a sheet metal part. Sheet metal parts tend to have a lot of shape to them, both the outer body panels and then the interior. This is basically like a firewall. So let's turn on the scan data for a minute. So you can see the scan data, we only had one side of it, which is pretty typical when you scan a sheet metal part. You scan one side, we surface model this all up, and then we offset and give it thickness, whatever the sheet metal thickness is. So you see here. But again, it started out as a surface skin. Again, doing a lot of that lofting and more of that intelligent surfacing, cutting out the holes and then giving it thickness. So this is, again, anytime you have parts, sheet metal parts or injection molded parts with a lot of shape to them, the smart surfacing is going to give you the most intelligent model ready for manufacturing. Okay, and one more here. Now this one you can see is yellow, which tells us it's a surface model, meaning there's no thickness to it. So it hasn't been thickened up yet. And let's turn on the mesh for a minute. So again, here's your raw mesh. And there's your surface body. Now, once we add thickness or we extrude this whole thing down, for example, if this is going to be a plug, let's say for a fiberglass application where we're laying it up, we would basically take this shape and extrude it down to a base because that usually the plug then gets machined out of high density foam or wood or some other material. But you can kind of see what went into making this, again, with the bigger, kind of more intelligent surface creation done here for this hood. Okay, to wrap this up, if you have, like I said at the beginning of the video, if you have any questions on any of this, you're confused or just want to understand this better, feel free to give us a call at 877-845-2700, or you can send us an email at info@ems3d.com. And, what can EMS offer you here? Well, we do this as a service. So we do this type of work every day. So maybe you're just looking to have a part 3D scan, have someone, turn it into CAD, reverse engineering, or you're looking to do dimensional inspection. We can certainly help you out. And like I said, we've been doing this for over 20 years. We've done very small, simple parts to very large, very complex parts. Maybe you want to buy your own 3D scanner and do this work yourself. So we can pair up the right scanner and the right software based on your needs, your budget. Happy to work with you on that. Or maybe you want some training. Maybe you've already bought the equipment and the software, and you really need somebody to help you how to do this, because this is the most complex type of modeling you're going to do with in regards to scanning and reverse engineering. Sketch-driven feature-based modeling is usually pretty straightforward. It's when you get into some of this hybrid and this smart or organic surface modeling, that's the stuff that's really the toughest stuff to do. And like I said, we've been doing it for a very long time on all kinds of applications and objects. So feel free to give us a call, but this and talk to us more, or send us an email. But this wraps up the video on the different surface types from 3D scan data.